copy this element. And I'm going to come here. So we know that stress X is negative, right? We know that stress Y is equal to 0. We know that stress Z is equal to 0, right? So stress Y, so this is the direction of our stress Y, and this is our direction of not. I mean, I draw too much curve, but right, if it should not curve so much, this is our stress Z. Okay. Then we also know that we have a shear XY or XZ, right, intersecting plane is equal to shear ZX. Okay. So we're going to sketch it out. Okay, we're going to sketch it out. So I'm going to sketch. Now, by the way, we are not learning anything new today, but we are integrating whatever we have learned from the very first day of this course up to last week. Yes or no? We are putting in everything together. That's why this course is it's not difficult, but it's the integration of different topics that makes it can make it difficult or overwhelming. Okay, difficult is not the right word. Overwhelming is the right word. Okay. Right. So I'm going to focus on the compression. I know. Okay. So this is our shear element rotate clockwise, element rotate anti-clockwise. So from here, we know that stress Y will be over here. Right? Stress Y. Okay, let me do what we have always been doing. This is our X. This surface our Y. And this surface over here, it belongs to our Z. Okay. So we know that our Y, point Y is going to be over here. Okay. So stress Y and stress Z share the same line. Okay. And then we are going to draw our stress X. Okay. So this is our stress X. Right. And then we are going to have a shear. Okay, hold on. Then we're going to have our shear line. So for example, this is our shear line. Okay, so that is our shear line. Okay, so we know that stress X, the X is going to do a clockwise rotation. Y is going to be an anti-clockwise rotation. Okay, so this, Z. Right. So now we draw our, we sketch our mold circle. Okay, so 3 square. So my circle is a bit. So I'm going to sketch my circle now. And then one somewhere around here. Okay, so the circle that we have just drawn, this belongs, as I said, this is a 3D mold circle problem. This is not a 2D. So we have our, this belongs to our XZ plane. And sorry, this is our XZ plane. So this is what we learned last week, okay? and this is our in plane, right? It has the biggest surface area, right? And then the next circle I'm going to draw, right? Remember, I told you this is a 3D mode circle, right? So the next circle that I'm going to draw over here, right? This is not a 2D element, this is a 3D element now, right? So this will be our YZ plane, and this is our out of plane, and the last circle that I'm going to draw, okay? So this circle that I'm drawing now, this belongs to our I'm having a tongue twister now. Belongs to our XZ, sorry, XY plane. Again, this is our out of plane. So what you can see here, our in plane, okay? So we have our stress A here. We have our stress B here, right? So the condition now we must use, right? We must use this. So the condition we have now is what? The condition is right, stress A and stress B are both or are positive and negative, right? So therefore, when that's the case, you go back to over here, when the principal stresses are positive or negative, you have to use this condition, okay? You have to use that tau max is equal to half of stress max minus stress mean, okay? So you have to apply this formula. Okay, you have to apply this formula. So we know that stress A is equal to your stress mean, and stress B is equal to your stress what? Max. Okay, so you have to find your stress max and stress mean now. Okay, so from here, we have to. It's not difficult. It's just procedure. Okay, so now you have to find stress max and stress mean. Okay, so these are your what? These are your principal stress. So let's look at our loads first. Okay, so due to okay, let's look at our loading condition. Then we start to plug everything in. Okay, and it's not difficult. Okay, what I'm trying to tell you, it's not difficult over here. Okay, so we're going to find the due to axial load, right? So we know that stress X is equal to minus 2,500, right? So 2,500 is the normal stress over here, right? So divide by the cross-sectional area, I C squared, and we're going to say that C is the radius of the shaft. Okay. Then we're going to find due to the bending moment, And the bending moment over here is, if we go back, is due to the M moment about Z, right? So stress X is equal to mz over izz multiplied by C, right? So the mz is equal to minus, now it's in compression, right? We know that it's in compression, so it's minus 18,000, okay, multiplied by C, divided by izz for circle is pi over 4 C about 4. So this will be equal to 18,000 times by 4 is 72,000 divided by pi CQ. Okay. I like to leave the pi down here because I don't want to handle too many decimal point now. Okay, that's the only reason. So now we know our stress in the x direction. So stress in the x direction is equal to minus 2500 divided by pi c squared, right? And then minus 72,000 over pi c cube. Okay. Now I'm going to stop over here. Let's go for a 15 minutes break. We come back at 8:45. Okay. I'm going to stop recording now.